Today we're going to look at Apert one more time when we have interest that's continuously compounding or population that's continuously compounding. Ugh. So to review, we looked at common logs. As mentioned before, the common log has a base of 10. The common log is used to measure many things like acidity on a pH scale, sound, earthquakes, the Richter scale. So for example, each earthquake level is 10 times stronger than the level before it on the Richter scale, and so we can see it's exponential because we're multiplying by 10 each time. So it kind of shows you an example of that right there. And just a reminder, whenever log is written without a base, the base is 10. So if I ask you to rewrite in exponential form, log of x equals 4. The common log is 10. It happens more often than other logs. So you could think of it as log base 10 of x equals 4. And then when we change it to exponential form, we start at the base. And we say base 10, the exponent's 4. Loop around. That will equal x. And then you can solve for that. So we know that 10 to the 4th would be 10,000. Okay, so there is changing from log to exponential form and solving. We started looking at natural logs. Population is one of many things that increases continuously. A bacteria population may double every 4 hours, but it's increasing throughout those 4 hours, not suddenly doubling in value when exactly 4 hours have passed. And so there's a special equation when something is continuously compounding. It's A equals PE to the RT. And so all these stand for things we've looked at before. A is amount at a certain time. P is the principal, like the principal of starting value. R is a rate. And so with rates, when we have a percentage, we've been changing it to a decimal. And with our other percentage problems, we've been adding to 1 or subtracting from 1. But in Apert, you just leave your rate as a decimal. You don't add or subtract to 1. And how do you know if it's positive or negative? If it's positive, it's increasing. And if you have a negative rate in Apert, it's decreasing. And then we have T is time, and then E is this limit. It's an irrational number like pi. It's a number that has no pattern, keeps going on forever. And this will actually help us figure out these populations that are continuously compounding. So E is programmed into your calculator. It's on the left-hand side, kind of where you see the log button as well. Okay, so here's what we need to know. Natural log, ln is the natural log, and it is the inverse of e to the x. So whenever you see log base e, you can change that to ln. So we'll do some examples. So solve for the following, for x. And again, if I change this exponential form to log form, we have log base e of 16 equals x. And again, here's the conversion. Log base e is the natural log. And we could type that into our calculator. Again, it's programmed in like pi is. So I'm going to pop this up here. And again, it's on the left-hand side of the calculator. On the Inspires, it is either yellow or blue, so you have to hit the control button first. Okay, so ln is right here above e to the x. So we're going to hit control and then e to the x, so there's ln, natural log. And we have 16. And then we get our answer. It's about 2.77. So let's write that down. X is about 2.77. Okay, so the only new part here is when you have log base e, you're going to use the natural log to solve. It's the only difference. And if you forget, you can actually type log base e of 16 into your calculator. So if you do forget that, I'll show you. So I could have done log base e, and e is right here. And if it's just e, it's e to the first power of 16. And we get the same answer, just faster to do ln. Okay. Let's do the next one. We have 4e to the 2x equals 22. Again, you have to get the base and the exponent by itself like we've been practicing. So the first step here, you would want to divide by 4 first. We'd have e to the 2x equals 22 divided by 4, just 5.5. Okay, change it to log form once you have the base and the exponent by itself. So we have log base e of 5.5 equals 2x. Whenever you see log base e, change it to ln. So we have ln of 5.5 equals 2x. Divide by 2 to get x by itself. And then I would type this into the calculator. So let's do that. ln, so again, control e to the x. And it was ln of 5.5. And that whole thing divided by 2. And it's about 0.85. Oopsies, maximize that one. Okay, so we get, I forgot the answer already, 0.85. So x is about 0.85. Okay, so there is using the natural log when it's base e to solve. All right, so let's try these problems. Assume $100 is deposited into an account, savings account at 6% interest, compounded continuously. When will the money double the original amount? All right, so when you see compounded continuously, that's A equals PE to the RT. We want to know, well, we'll start with $100. I'll put that in first. And then E is that number 2.7818, so on. The rate here, change 6% to a decimal, but don't add or subtract the 1 in Apert. So it's going to be 0.06. And then we don't know time, but T. When does the money double the original amount? So I'll put equals 200. Okay, so here's plugging into Apert. Now we solve. We want to get the base and the exponent by itself, so I'll divide by 100 first. We get 2 equals e to the 0.06t. Let's change this to log form. So base is e, so log base e of 2 equals 0.06t. Again, here's the new part. Whenever you see log base e, that's the natural log. So ln of 2 equals 0.06t. Let's divide by 0.06. And then you can just type that into your calculator. So we have ln of 2, where's ln? Divided by, oops, forgot the 2. Divided by 0.06. And we get about 11.55. Okay, so here it is. X is about 11.55. You can check your answer. You can type this in and plug in for t. So let's do that. So we have 100 e to the 0.06. Oops. And instead of typing in 11.55, I'll use control negative. The answer key is more accurate. And we can see we get 200. So you can check your answers for these once you get one. All right, Esther invested $1,000 into a certificate of deposit. A CD is another way to save money. 3 years ago, the CD is now worth $12.70. Assuming the interest rate was compounded continuously, what was the interest rate? So again, we have A equals PE to the RT. Okay, so we knew the amount after a certain number of years, 2070, equals our starting value, 1,000. E to the rate, we don't know the rate, but we knew the time 3 years ago, so R times 3. All right, let's solve this. First step, divide by 1,000. Okay, so we get, let's change colors here, 1.27 equals e to the 3r. I'll just change the order of that right there. It is, we have the base and the exponent by itself, so let's change it to log form. So log base e, I'm just going to write ln right away. Log base e of 1.27. Oops, I'm out of room, so let's write it smaller. ln of 1.27 equals 3r. And then last step, divide by 3. type that in, ln of 1.27, close my parentheses, divided by 3, and our rate is 0.0796. I'm going to round that, so it's about 8%. All right, so there's our rate, about 8%. You could say 7.96% would be more accurate. And again, you can check your answer by plugging back in and making sure you get 1270. Make sure you use the answer key so it's more accurate. Okay, Marcos plans to invest $500. And I know it's compounded continuously at a rate of 8.25% interest. How long will it take for his money to triple? All right, so that would be $1,500. And then the rate is 0.0825, and we get our t. Okay, first step, divide by 500. We know that's when our money is tripling, so we have 3 equals e to the 0.0825t. We know it's log base e, so I'm just going to write ln of 3 equals 0.0825t. Last step, divide by 0.0825. Type that in our calculator. ln 3 divided by 0.0825, enter. And so our time here, I'm out of room. So time equals about 13.3, and I forgot, was this years? I'm assuming it's years, it doesn't say, but I'll assume it's years. There it is. Last one, and then we'll do a quick summary of the 3 different formulas. A certain strain of bacteria grows compounds continuously from 40 to 326 in 120 minutes. Find R if T is in minutes. Okay, so we have 326 equals 120 E to the R times 120. Okay, so I put that 120 in the wrong place. Okay, so this should be grows from 40, I'm sorry. So 40 to 326. Okay, so we plug in. Next steps, divide by 40. All right, so we have 8.15 equals e to the 120r. Change it to log form. Again, it's log base e of 8.15 equals 120r. Remember, log base e is ln. So you could have just written ln of 8.15 equals 120r. Divide by 120. Okay, so ln of 8.15 divided by 120. And so we get our rate is 0.017, oops, 5. It's 0.017483. So it's about 1.7%. Now, if you get a rate, because you will encounter some, if you get a rate that's negative, that means it's decreasing. So when you see something decreasing, you should expect a negative rate in Apert, and it just means it's going down by that percent. All right, so here's a summary of the formulas, 3 of the 4 formulas we've been looking at. So simple interest is when something happens once per year. It's just starting value. Change the rate to a percent, add or subtract the 1 to the n power. If it's compound interest more than once a year, again, change your rate to a percentage, but divide by how many times a year you're compounding it, and then take it to the power of multiplying it by how many times a year compounding it, times the number of years. And the last one's the Apert equation we spent looking at today. So let's take a look at how that affects money. $1,000, to be exact, into an account. How much will you pay after 5 years if the interest was 4%? All right, so annually. This is the first equation, so I'll put A here. So A equals 1,000. 1 plus, change 4% to a decimal point, 0.04 for 5 years. Let's type that in. Okay, so after 5 years, you will have 1216.65. Okay, let's do quarterly. So it's compound interest more than once a year. So start with $1,000. 1 plus 0.04. But now quarterly is 4 times a year, so we're going to divide 4% by 4. And then again, it's for 4 years, but for 4 times a year. All right, so we type this in, 1,001 plus parentheses 0.04 divided by 4. Close our parentheses to the power of 16. That's 4 times 4. And we have Oh, it's 5 years. I was wondering why. Okay, so I need to change this. This should be 5 years, not 4 years. All right, retype it in 1,000. Parentheses 1 plus 0.04 divided by 4, the power of 20. Okay, so we will get 1220.19, so it's increasing when we do it 4 times a year versus every year. All right, monthly, 12 times a year, so the amount equals 1,000. 1 plus 0.04, but now it's monthly, so divide by 12. And then it's 5 times a year, or sorry, 5 years, but 12 times a year. All right, so we'll type that in. And this is times. Okay. So 1,001 plus 0.04 divided by 12 to the power of 60. 5 times 12. All right, and we get 1221. So it's slightly increasing. And then there's a limit, so this continuously compounding will give us probably the most interest, but it does cap off. So A equals PE to the RT. Our rate is 4%, don't add the 1, and that's for 5 years. Okay, so type that in. Oops. E to the rate 0.04 times 5. And we get 1,221.40. So if it's continuously compounding, it's only 40 cents more than every month. All right, so your assignment, you're going to practice these ideas, and then we'll review.